My name is Matt Taylor. I'm a front-end engineer here at Yahoo, and I'm going to be talking about view rendering. The main topic of this is very simple. Taking data in any format, such as this, transforming it into another format that we can render in a browser. So anytime, at any point, that's the context that we're in, and how to do this in different ways using JavaScript on either the browser or on the server. So just in case you didn't understand the pretext. So this is, I want to start off with this to show you an example of modules, or what we might call modules on the page. So everything we have kind of outlined here in red is something that the server is most likely pulling together from different data sources and taking these data sets and running them through some form of templating engine to get the actual markup that's then assembled on a page assembly server and pushed to the client. So when I'm talking about view rendering, I'm not necessarily talking about the entire assembly of this page. I'm really just talking about taking the data for each one of these different widgets or modules or whatever and rendering it into a viewable state on the browser. So kind of individual modules and their renderings. So the typical way that this is done in the past is pretty simple. There's a client that makes an HTTP request. And then there's some server that is in charge of putting that HTML together and sending back to the client. There could be n number of data sources or data stores that this server might go query for data and pull data back before it does its assembly. And typically, that data is pushed through some form of templating engine on the server. So it's sent to the engine. It may be local there on the server, just a module. It may even be done on another server. But essentially, that data is transformed by the templating engine into markup that's then assembled into a page and sent back to the client. So that's kind of the typical view rendering route. But that's not really what we do much anymore. So the typical thing nowadays is to, well, you have to have the page assembly done at some point, and the HTML passed back to the client. So there could be many trips from the web app server to some data stores, wherever they may be, and then a portion of the construction, which is page assembly, pulling all those things together, putting them together, and sending them back to the client with most likely a chunk of JavaScript and CSS. And then there's a startup of the JavaScript application on the client. Then subsequently after that, we'll typically make XHR requests. And the way I like to do it is I don't want to get markup typically from my server. I would rather them send me the data. And I'll manage to update the DOM once you've sent me the data. So this could be more of a typical way to do it now. After the app is started up, you have everything in place to make these XHR requests, assemble the data that's come back into DOM manipulations, and continue. But the problem here is that we have these two places where essentially the same job is being done. So if you were at Dave's talk earlier, you see there's a lot of potential using JavaScript on the server to try and do this in one place. So this is like a typical example of client-side rendering. You go, you make a call to the server, you expect to get JSON data back. This is just a trivial example, but it's a good example. In the success callback handler, I'm just going to parse some JSON. I'm going to grab a node, and I'm going to do some manipulation on that node. All that I really need in here is a node instance, a wide node, and then some data that I know what its format is going to be. On the server, who knows really what it's doing? If you're concerned only with the JavaScript application running on the client, I don't know how the server is doing any of its data rendering. But I know it probably has a data set, because it's got to have data for each one of its modules, and it probably has a template. And so it squelches those together in a template engine and magically produces HTML. One thing is you can have different flavors of templates to produce different flavors of HTML. And that's all in good. We can do the same thing on the client as well. So the whole point of this talk, and you may have gotten the gist of this from Dave's talk as well, is we want to take these two things and only do them once and push them together so we can have one code base and everybody's happy. So let's start from the client rendering side, first of all, and say, how can we move towards that goal of having this one piece of code that does this rendering, that accepts data, and pushes it into markup? Well, let's take this callback out first. And instead of just having it sitting there as an anonymous function in our success handler will pull it out and turn it into a function that accepts a node and data. Once we have that sort of just out of that scope, why does it even have to be in the same file? We can put it anywhere we want to. We can put some script out there sitting on the web that matches a signature that we expect once we load it, so that we can push it a node, push it data, and it will just execute. We can have lots of these. We could have one data set that we know our server is constantly dealing with, and we could have lots of different flavors of renderers for it, depending on the context in which it's rendering it. So this is the potential here. Push all of that rendering out on the web somewhere, so that we have flexibility of loading different renderers without a templating engine, because that's what I'm trying to get around. We can't run a templating engine that's run on the server on the client, but we can run the JavaScript that we're doing our rendering on the client on the server if we have a runtime and we send it the data as well as that rendering function that we just pulled out and put on the web somewhere. So that's kind of the premise of this. Get rid of templates on the server and have Node.js running as a rendering engine to do this for us. I already mentioned Dave. All of the prototype that I made for this talk is very heavily using Dave's work with YUI 3 on Node.js, and on top of Elijah Insua's work providing that JS DOM library that we're using. So I just want to give a shout out to those guys because that's brilliant work. So this is more of what I'm going to show you today in this prototype. So for the browser side view rendering, because there's totally two ways this could work. So if we want to do this view rendering on the browser, it starts off the same way, a request from the client. But then the page assembling server that's putting all of these modules together is going to render no HTML for this. All it's going to do is it has to know for each data set that it goes and gets, it has to match a rendering URL, or excuse me, a URL to the script of the renderer for that data set. So potentially each different data set that the web server is putting together to make the page could have a different rendering script associated with that exact data signature it's getting from the set. But that's the same problem that you would have if you have a templating engine, because you have to match it with a template. So we're not creating any complexity here. Once it has retrieved its data from its different sources, and it's matched it with the rendering URL to where the client can go and load the script to push the data through, it just has to send that back to the browser. So no markup is being sent to the browser except kind of like an empty page template with placeholders for where the different modules are going to be. And I heard someone mention Big Pipe earlier in the talk, and it's kind of similar to that idea too. You render a page that's like a skeleton, and then AJAX calls are made to populate the different parts of the page. So the browser, once it gets this request back, and it's got 10 modules or so on the page, for each one of those it can go load a URL somewhere that it knows matches that JSON data that it gets back, and then execute it right there. Just push the data right through the function that it just rendered. And the DOM is updated at that point. So, okay, if we're going to do this on the server, say we want to return markup to the client now. We want the server to render that markup. So we can go almost the same route, but instead of pushing the data to the client, we just push it to another server. So in this case, the page assembly does the same thing. It goes and assembles all of its different data sets, and it matches it with a URL to the renderer for that specific data set. And it pushes that to another server, not the client. So we're just going to defer that responsibility to the rendering server, which will then do the same thing the client did, go and load each of those scripts, and then push the data through it. In our case on the server, however, it can't just update the DOM and expect things to be great, because that DOM is just kind of an imaginary DOM that exists on the server. So it has to output a string. So it just does an outer HTML of the DOM node that it's just manipulated, so that it can send that markup string after it's done all the evaluation and rendering back to the page assembly server. So it's just got markup strings, and it just puts them together like it normally would, as if that data was coming out of a templating engine. So at this example, the browser just gets markup. It doesn't have to have any JavaScript. It just gets markup. So I've got an example, kind of a prototype of this whole idea out on GitHub. There's a tiny URL on top if you don't want to remember that whole big name. But this is what I'm going to kind of demonstrate. And when I did this, we built this as an internal Yahoo Hack Day for Summer Hack, and we used proprietary Yahoo technologies to kind of do this. So for this talk, I wanted to move all of that off into the open source world. So we built this prototype using Grail's web application as just the page assembly server, and then a Node server, and then all the client code is stuff that I just wrote. We do have internally at Yahoo a framework that easily handles all the client code that you're going to see that already has that pretty much built. But I wanted to give you totally open source code. So you can go here, download this example, and run it pretty easily. You just have to have like Java for your page assembly server. So now I am, there we go. So now I'm going to show you the actual demo. So I'm in my page assembly server directory in this GitHub that I showed you. I'm going to start up the Grail server. This will take a little while, but the Node app, which is the rendering server, which I also have to have start up because they communicate to each other, is not going to take long at all to start up. So while Grails is still starting up, I'm going to show you these two examples again. First, we're going to see the browser-side view rendering, and I'm going to show you the website running, and we're going to set up some logs so it blocks every time something occurs, so we can step through this and see exactly how this is happening as soon as my website starts up. So what's going to load here is a website with 2 modules. I only did 2. And you're going to see a list of enemies of Doctor Who on the left, and you're going to see a list of all the different actors who've played Doctor Who on the right. And it's just some sample data that I threw together because I'm a Doctor Who fan. There we go. So the initial page load is using, and I'll show you the different parts of the page here, is using entirely the templating engine that comes packaged up with the Grails web server. And it says right here in each one of these pages, it's going to tell you how these views were rendered. This was rendered using the default template engine for Grails. So nothing spectacular is going on here. And if we look at these modules, like I said, there's one on the right here, and it says rendered by Grails. On the left, rendered by Grails. So we've got 2 modules on this page right now. So what I'm going to do is I've got some links in the middle. I'm going to tell it render on the client and kind of show you this. And so you're going to see a couple of AJAX loading dialogues over here because there was initial page render that didn't contain any markup, just empty nodes for those different modules that were going to be rendered. And then 2 AJAX calls that are being made up to the server to get data for those modules. And it also came back with a rendering URL. So let me turn on logs here. And it might seem like it's taking a while, but I put kind of a wait on the server. So I put like 500 milliseconds wait. So you can actually see the spinner come up, or else it turns pretty quickly. So on the initial page load, we've got nothing, and 1 module is trying to load right now. So as soon as the page loads, the code kicks in and starts trying to load something. So I've got a YUI3 module called AJAX Module Loader that basically handles all of the calling for data for modules, the loading of the rendering scripts for them, and then pushing the data through the rendering scripts that updates the DOM. So in this case, it's saying loading modules doctors, which is the one on the right. So now we can see it's executing the XHR request for doctors. So it's recognized there's 2 modules on the page. It's doing doctors first. And now this is the other one. If you look at the little arrows, they're different colors for the different 2 modules. So now it's loading the other module, and it's executing XHR requests. So we should get some responses back. I've got a response for the 1 module. Now it's parsing the JSON for that module. And now it's loading the renderer, which I placed out there on my web server at that URL. So the JavaScript whose responsibility it is to take the data that contains all of the Doctor Who's hasn't even been loaded at this point. So I'm just using yget to load this. So now, in the meantime, I get a response from my other module, and now it says that the doctor's renderer has been loaded. So that means it's been loaded, it's been evaled, it's ready. The function that I have sitting out there on the web is now available to be called. Now we're actually calling the renderers from the module loader, and this log just came from the renderer itself. So from the JavaScript file that it just loaded so that it could render the data, that's where that log came from. And it says it's rendering it into the doctor's container node, which is the ID of the node that I want that module to render into. So now the page sees, oh, one module's loaded. And there you saw the DOM update itself, because the renderer just executed, directly manipulating that DOM and put everything in its right place. The page sees one has been executed. We're still receiving the JSON for the enemies. And now we're loading the renderer in the same exact way. It is loaded, and it's calling the renderer. And now the renderer has just executed. That's where that log statement came from. And now that module is loaded. The page sees 2 modules have loaded. And the page sees that all modules have loaded. At this point, there's an event that fires, okay? Because this is where there may be a bit of a gotcha that I'll go into when we start rendering on the server. But I may want to attach events to this markup that just occurred. I cannot do that in the rendering scripts, because that could potentially run on the server. And if you start attaching events to a DOM that's running on the server, nothing happens. Right? I mean, on the client. It's a made-up DOM. There's 2 separate DOMs here. So in these rendering scripts, you cannot do anything with events. There's no binding. Do not bind. It's only just for rendering. And there we have the full page. So now I also have a button here called Render on Node.js. When you render on Node.js, it takes a while just because I don't have anything optimized on my machine. But the same thing occurs, except the markup comes immediately, obviously, because all of it was rendered on the server. There are no placeholder nodes. Everything just comes rendered. But there's still that step of attaching the event handlers, because that code still needs to run on the client, even if all the markup's coming from the server, because no event binding occurred at all during that rendering of that data into the view. So we're still doing event binding here. And as you can see, this says rendered by Node.js. That is a parameter that's sent into that rendering script. And I'll show it to you. So the rendering scripts look something like this. This is all just prototypal code. So the standards that you might see here are just things that I conjured. So, take it with a grain of salt. But basically, what I've got here is I'm saying there's a namespace called renderers that I'm just going to assume is going to be a global variable. That's where I'm going to put all of my rendering scripts. That's where they're going to be loaded. And so, for example, let me go to the doctor's one, because that's what we saw. It accepts some options, and what I'm expecting there to be is a node in that code, or in whatever's calling this. The thing has to have a node, a Y node, a YUI node object. That's what this renderer needs. And it also is expecting the data. So another kind of gotcha is this renderer is expecting a certain data format coming from the JSON data that's being pushed into it. It's just a JavaScript object by the time it gets here. So if you mismatch your renderer to your data, just like if you mismatch a template to the data in your templating engine, things are just going to break. But, I mean, there's potential for standards to be set up for this sort of thing. So all this is just a function. All it does is expect Y node to be sent and some data to be sent into it. The actual module that does the loading, I'm not going to show you too much of it. Actually, it might even look better here. Go to the client. Walk through this. Sorry, I should have turned that off. I can still view source. Yeah, I can view source without that. So all that we're really doing here, and this would probably look better in TextMate, so let me load that real quick. This is my page template. So I'm still using the templating engine to assemble my entire page. What I'm deferring is the rendering all of the different modules on the page. So what we have here is the use statement where we're actually doing all of the module rendering. And the call that actually does it is for each of these dynamically loaded modules, which is just a unique ID or a unique type of module that identifies what the data set is and what the renderer is. I'm just looping through, grabbing a node that I know that I'm going to use, and pushing it into this load module function. And all it does is you send it a data type, you send it the node you want it to update, and then you can send it a callback. In this case, all the callback is doing is turning off the Ajax spinner graphic, just removing the loading class from it. So now I've got to step through this. Sorry. I couldn't figure out a way to do this step by step without alerts. So, but when we render it with Node, let me show you the source with this. You'll see that there's hardly any JavaScript. It's just markup, tons of markup. It's all glommed together. But there's one little snippet here, and that's the event firing that all modules have loaded. Because like I told you, you can't bind you can't do any event binding in your rendering scripts on the server. So if I've got some interactions that I need to set up, and I do, like this, I've got to set that up afterwards. So Node might render all of my markup for me, but I'm still going to have to do something that's going to attach my event handlers. So that's the case here. So I've actually got 3 modules on this page. There's the enemies and the doctors, and then that doctor detail box that I just popped up. So when I turn on the logs for this, right now we've just rendered on Node.js, but by default this will render on the client. We can look and see exactly the same thing happening. A node was clicked. That's just coming from the event handler. We're going to load the doctor detail module, which is a different module, doing an XHR request. A response is received. We're going to parse it. We're going to load the renderer. And then after it's loaded, we're going to call it. It's going to update the DOM. Inside the renderer, it's saying what it's updating. And then we show it in an overlay. So it's easy enough to also do this. I'm just going to check to render it on the server. And the same thing occurs, except the node's clicked, but you'll see that all the markup just comes in one chunk. There's no rendering going on the server or on the client because it's all being done on the server. So we see the response contained a markup string, not a JSON object. So that's going to mean we don't have to attempt to render anything, but we are going to still bind. So we're setting the markup response into the overlay. In this case, this markup doesn't have anything that needs to be bound, but if it did, you would have to do the binding here on the client yourself, showing the overlay object. And there it is. So in each one of those, you can see, just as proof, this was rendered in Gecko because I've got Firefox on. So if I turn this to render on the server, in a couple seconds it'll pop up and you'll see it was rendered by Node.js. Now if we look at the server logs here, we can see more interesting stuff occurring. So on initial page load, let's go back to render on the client. The website is hit immediately. Page assembly is starting. It's rendering the modules on the client. It already knows. So at that point, it sends all the markup, and all it's doing is waiting for AJAX requests. As soon as it gets an AJAX request, it dispatches it to the right place, and it just returns data along with a renderer, a URL to the renderer. On the node side, let's do this again. I'm going to render on Node now. You're going to see some stuff occurring here. So render start, and Node is going to do the exact same thing. It sees the URL, it's processing it, it's evaling it. It's a little quick and dirty, but it's just a prototype. I did actually get to set up a little bit of caching, so it'll cache these. It won't load them more than once. And then it's rendering the data. It is sent, and then it sends back the whole markup to the server. So there's some interesting things to think about, and one of them is, there we go. So if we want to take this a little further, let's say if you're a big company like Yahoo, you might have some properties that want to serve other properties. So you want your sports stats or something on your profile page. You can have some of these properties open up web services that will not only deliver the markup, but might just deliver data and also deliver a renderer. So you could call in these services, get my data, get my renderer, and then have your web app server use these. You could use this as kind of a base vanilla renderer. Let's say it's just going to give you straight markup. You're not going to attach any classes, just valid markup that the property or whoever is doing this provision knows is the base of what it wants to send to people. And then you could go get a renderer that you're hosting on your page assembly server, something that decorates that DOM after it's already been passed through this renderer. That DOM could then, or that renderer, both of these renderers could then be sent to the rendering server and kind of executed in queue. So this wouldn't be too simple to do. The prototype doesn't do it, or it wouldn't be too hard to do. This prototype doesn't do it, but it makes sense. You could have this rendering server execute any number of renderers. So you could have different kind of phases of rendering, one for just vanilla markup, one that adds classes, one that does, I don't know, click tracking or something. So you could get these renderers from all these different sources. Once they're in the browser and they're rendered on the browser, they would be cached. Your Node renderer could also cache these things so that you only pay the loading of that, the cost of loading that JavaScript wants. And then you could potentially push one data set through any number of these renderers. So that's one possible extension to this whole prototypal idea. Also, another interesting thing is your page assembly server knows what your browser is. So it should know, like, if you're running WebKit or Gecko or whatever. It might be more likely to defer the rendering to the client because it knows it's probably got JavaScript enabled. If you've got the cookies to check for JavaScript enabled, so it could defer some of the load, the server load of using our own servers onto the client. So that and it can do that by module. It could say 50% of my modules I'll defer to the client. The other I'll just render right here with Node.js with the same code, the same rendering code. And it could even have a status of what the CPU load of the Node server is, and decide whether it's going to defer loading to it based on its load. The rendering engine could be an array of servers. It's very generic. Nothing specific needs to be on there. All it knows is it's going to be accepting some data. It's going to be accepting a URL that's going to push the data through, and that's just what it does. So, again, although the prototype is capable of handling this, I don't have an example of it. But instead of pushing or just telling the renderer to start with the total blank node, because your renderer is going to either assume that the DOM it's given is empty and it's going to build up from there, from an empty node, or it may assume that it has standard markup, like if the module provider had provided a renderer that's already been run. So it could be in like a decorator mode. In that case, that markup could be either cached or stored on the rendering server, or it could be sent from the page assembly server. Meaning, if I don't want to start with a blank node, I could just send a markup string and say start with this. So on the Node server, from Dave's talk, this is fairly simple. You just create a DOM and push some markup into it, inner HTML, straight into it. So now you've just built a little DOM node that represents your view. And then when you run the render again, you have a starting point. So you could tell it where you want it. Within that, you could provide a selector where you want the node to start building. So you could kind of build subnodes within that. Or you could just have it decorate the entire thing. So there's a lot of potential to do interesting things. And there's nothing against running Mustache on the client or on the server. If you don't want to do it in this manner, which is just a function that takes a node and data, you could create Mustache templates and have those cached on the server or the client, and go that direction too. So I will show you some of the Node code a little bit, although I don't want to get too deep into it. But if you saw kind of Dave's talk, I'm building entirely on what he did. He's got an example up there on YUI Node.js on GitHub, and I just took that example and I stripped some stuff out and I added some stuff. It's not that bad. Almost all of my work is done in a renderer, and the function just looks like this. It's accepting data, a URL, the page, which is the node, which is the document object that's been wrapped in Yahoo or in YUI. A callback and whether to force a reload of the renderer or not. But there's a bunch of callbacks involved in this code, so I'm not going to get into it. But there is a step to load the renderer, and then there's a step to execute the render, and then there's a step to execute any callbacks that were sent to it. So it's not too much of a complicated concept. So yeah, I'd be happy to take any questions after this, but I want to note that this is all just a proof of concept. This is entirely a prototype. I hope that you guys take this GitHub and fork it and do whatever you want with it. It was meant as kind of an addition to a current web stack. So one of the selling points of an approach like this is you don't have to change your web application stack. You have to just add to it. So add a Node server sitting out there somewhere, install some code so it can do this type of thing, and then you don't have to change your web server that much to add the capability to defer rendering instead of your default templating engine to this Node server to do it. So it's not like you have to use Node.js for your web application. You can use it kind of as a side to do this. So it's not really a move towards Node.js as page assembly, in which case you might use something like Express to actually, the MVC and Express to do the whole web framework part of it. It's really just using Node as a fast rendering engine off to the side. So obviously all my demo code is open source. And I'm still, wanted to emphasize this again, the page assembly is still being done using Grails GSPs, which is Groovy server pages, not JSPs. So, do you guys have any questions?
The event handler that they just split out and rendered with Node.js, isn't this you distinguish between everything is rendered and I just add this line onto the page?
Mm-hmm.
The Node.js knows how to split all the JavaScript that's already rendered and just leave the events by itself?
Well, so the renderer, I think you, maybe I should repeat it because I don't know if I understand it, but the renderer in each one of these little rendering scripts, there's nothing going on here that's doing anything with events. I'm not attaching any events on here. So the code that runs on Node doesn't do anything with events at all. All it's doing is appending things to the DOM, and then at the end it returns the whole inner HTML of the node that it just augmented. So even if you did try and bind events on here, even though the code wouldn't fail because YUI is obviously available, you wouldn't get any of the benefits of it because all I'm doing is creating a DOM string. So this doesn't add any JavaScript to the markup that it's returning back to the page assembly server at all. So that's kind of the catch there, is this is render. So if you think about YUI, this would be the render UI phase and in the widget API. Once it gets onto the server and it's loaded, there's a trigger that all modules have been loaded, and then there's another script here that actually does the event attaching for that little doctor detail pop-up. So this is what runs when it's listening for all modules loaded. So here is the bind UI step, right? So I'm kind of manually doing this because I know the stuff that I'm getting from the server, the stuff that the client's rendering, has no event stuff in it at all. So you have to kind of add this step, and all I'm doing is just going and looking for all of the doctor H2s and just adding click handlers on them. And that then is where we're, again, calling that load module every time it's clicked, giving it the node that we want it to update, and going through the same process again. So all of this stuff is done in the bind UI step. Anybody else? Sure.
Do you trigger that all modules loaded thing? How do you know when?
Yeah, let me show you. So actually, let me show you in the code. So this is the markup the JavaScript for client-side rendering. Okay, this script is dumped every time I'm doing client-side rendering because that's where I'm actually making the AJAX calls to load the modules. So inside of this event handler, this is run every time any module is loaded. So this is my callback when I do that. I want to run this. I'm checking, okay, so I know how many are loaded. I'm just going to do a count. If they're all loaded, I'm going to fire that all modules loaded event so that anything else, any other sandbox on the page that might have event binding that needs to be done after this is loaded can listen for that. So it's a little down and dirty, but it works. The node renderer portion of it, okay, so this is the JavaScript that's sent when it's rendered on Node. And all it does is fire that event because it's already loaded, right? because the markup came along with the response. So just on DOM ready, it fires the event. And each one of them includes the actual handler that does the event binding. It has to. Any other questions? Gary D.
So this is pretty much the life cycle that we have today in YUI widget implementation. Any plan to extend that to support rendering the server side?
Yeah, that would be interesting. So Carity said this is kind of the life cycle we have currently for YUI widget, which is true. You know, the render UI, bind UI, sync UI. So yes, I've thought about that, and it would be interesting to do an implementation of some module, some object that extends widget that just knows how to do this. You know, if it's hooked up properly. So yeah, that would be kind of a natural way to try and drive forward.